Hello class, welcome to our lesson today. Again, we're looking at triangles like what we did in our previous lesson. So let's go ahead and get started with some review questions about cross multiplying, and then we'll get back to triangles. Remember when you're solving proportions such as these, of course there's other ways to find the answer. For example, you could multiply across or multiply up and down. But the skill that you want to make sure that you know how to do is to be able to cross multiply so that when the numbers get more challenging, you'll be able to find that answer fairly quickly. And so for this scenario, I've got 4/5 equals x over 20. So it'll be 4 times 20. Okay, if I multiply these two together, equals 5x. Remember, after that, you would have to divide by 5 to find that answer. I wasn't going to go over every single one of those questions, but just getting the setup I thought would be most helpful to you. So for the second one, 4 times x is 4x, and then 6 times 14. And then to find x, you would divide by 4 on both sides. If you don't mind, why don't you make sure you try out this first one. Most common mistake on this first one, if you look at this originally, is that some students try to cancel the 4 and the 8 and make them a 1 and a 2. You can't really do that here because when you're solving proportions, you can't cross simplify because they're on different sides of the equal sign. So something that you want to make sure that you think about is you can only simplify on the same side of the equal sign. So like if this was 8 over 10, then I could simplify these two on the right side. But I can't simplify the 4 and the 8 in that regard. In the second one, I would have 5 times x equals 9 times 19. I went ahead and solved all of this piece. It's okay if you get decimal answers. Some of your questions may ask you to round to the nearest tenth or nearest hundredth. That's something that you want to continue to work on as you're looking at some of these questions to make sure that you're finding answers in the appropriate manner. Okay, this is straight from your textbook. There's a lot of different information here. Classifying triangles by their angles and their side lengths. So an acute triangle, all the angles are less than 90. An obtuse triangle, notice there's only one obtuse angle because you can't have more than one obtuse angle in a triangle. Otherwise, that would be more than 180 degrees. Similar for a right angle, 3 right angles. Now, an equal angular triangle is probably one that you haven't heard said very much. You've probably seen equilateral, where all 3 side lengths are the same or congruent. But 3 congruent angles, an equal angular triangle is a special version of an acute triangle. Okay, it just happens to be that all are the same, and if all 3 angles are the same, 180 divided by 3 would be 60 degrees. By their side lengths, you have what's known as a scalene triangle. Okay, that's no congruent sides. An isosceles triangle, this might be a piece of information that maybe you didn't realize. An isosceles triangle, by definition, has at least 2 congruent sides or that are equal measure. So what you'll notice here is we have these tick marks here on this picture. These tick marks represent that they're the same. Now, a special isosceles triangle is what's known as equilateral, where all 3 are the same. Okay, so notice there's a tick mark for each one of these sides. All 3 are the same. So an equilateral triangle happens to be a special version of an isosceles triangle that all 3 are the same. Most of the time when you classify, you're going to classify the best answer by angles and the best answer by side length. Okay, so if something is equilateral, we're going to say the best description is equilateral. And just realizing that that's just a special version of an isosceles triangle. Okay, so classifying wise, what you want to look at, there's no numbers here, but just look at the angles and that should help. So there's a 115, so that's going to be obtuse. And then if all the angles are different, what we'll start learning in geometry classes and things like that are the sides opposite kind of go together. So this 115, the longest side is over here opposite of it. Okay, it's kind of looking at it. But if none of the angles are the same, there's no way any of the side lengths are going to be the same. And so that would be what's known as a scalene triangle. No numbers here, but we have the congruency markers. Notice the curves, the arcs for the angles, and the tick marks for the side lengths. So this is an acute triangle. All of them are less than 90. And this is isosceles because these two match up. Okay, drawing triangles is not a challenging aspect as long as you have your protractor. Now, drawing a 90 should be really easy. Okay, make sure you put the box in the corner to represent 90. 30 degrees should be less than the other one, so you don't want to make it look like an isosceles triangle where they're all these two other angles are the same. Okay, so we've got a 30-degree angle here and a 60-degree angle here. Notice that I labeled those things to make sure that we knew what we were looking at. If you had to draw this yourself, okay, I would suggest drawing the 90-degree angle first, and then from this point, draw 30 degrees, and just keep drawing this line until you meet up with the other line. Okay, and then this would be a right triangle and a scalene triangle because none of the angles are the same. Okay, this next question, you're going to have some drawings where you have to use a ruler and a protractor. I know not everyone has a ruler readily available, so at least make your picture somewhat accurate. Okay, remember the kind of the width of your pinky finger. Okay, the width of your pinky should be about 1 centimeter. So just kind of estimate that distance. What I would be looking at is, okay, this 5 centimeter length should be a lot longer than 3 centimeters, and just that it's close to that. So for example, I shouldn't have it take up the whole page because that's definitely not 5 centimeters. So that's something to think about there. Drawing this triangle, I would probably say draw this 5 centimeter length first. Just draw from dot to dot, and then measure 75 degrees from one of them, and then just start drawing, and then you'll measure this side length to say, okay, that's 3 centimeters then. And then I cut it off and then connect the third side. You're going to have to practice some of these things. So I know it's very tempting just kind of just draw it quickly and move on. Okay, you want to make sure that you're drawing things accurately. So the 5 centimeter length first, draw the angle out, and then cut off that angle at the 3 centimeter mark as you're looking at it. This one's a lot harder to see if it was scalene and acute. For example, if this angle's close to 90, it might be hard to tell. So you can always use your protractor as long as you're using a straight edge to find that. Probably scalene at that point. These two aren't the same. Doesn't look like it. It's probably the same. But if your picture is drawn accurately, that'll make it a lot easier to tell about the classification. Next thing we need to talk about are what are known as similar triangles. So when you say two things are similar, they kind of look like each other, but they may be different sizes. Okay, so the idea of like a small regular version of a candy bar and a king-size candy bar. They have some similarities. They're a little bit different size-wise, but they have same properties. Same idea. Okay, for triangles, similar triangles have angles that are congruent. So the angles are the same. So notice here I have 1 and 1 for the curves. Okay, one arc and one arc. Those two are the same. B and D have 2, which means those two are the same. And C and F have 3, which means those three are the same, or those two angles are the same. And then the corresponding sides are proportional. Now remember, proportional means they make the fraction or ratio equals of another ratio or fraction. So for example, 7 over 14 equals 6 over 12 equals 10 over something. This one's pretty easy because it's just times 2. You want to make sure that you're able to set up a cross multiplying approach with the proportion idea in order to find those answers as well. So the first question is, are these triangles similar? Now triangles are really easy because you don't have to look at the side legs as much. If the three angles match up, then it's probably in really good shape to start with. Okay, so notice here, one arc, one arc. Those three are all the same. They each have a 2 arc and each have a 3 arc. Okay, all those pieces would be identical, so the triangles are similar. Now notice, this one's kind of rotated around. That's okay. Okay, you can rotate something and still be in a similar shape. It's just that you've moved it in a different location. Okay, our homework today, section 7.3, 6 through 14, number 17 and 21 through 27. Okay, I want to make sure that we're clear about a few things. You have to make sure that you're drawing some things accurately. Make sure you read directions. It's important that you're reading those. A lot of people are missing some points on assignments and tests because they're not reading directions about how to label things, or for example, describing the triangle in both the angles and the side lengths version. Some of those things are things that you want to look at as you're dealing with these scenarios. Have a good day, everyone.